Hi, today we're going to study the 6 basic functions that we study in Math 3. And the first function we're going to look at is the linear function. And we know this is linear because the function reads f of x equals x. There's no power. Well, the power is 1, which makes it a linear function. This function sets y equal to whatever x is. That's called the parent linear function is just y equals x, or f of x equals x. So if x is -4, that means y equals -4. And if x equals -3, y equals -3, etc. So we'll fill in our table, and y just equals whatever x equals. And then we're going to plot the points. So at the point -4, -4, I go to -4 on the x-axis. This is the x-axis. This is the y-axis. So I go from the center of the origin, 1, 2, 3, 4, in the negative direction, and down, which is the negative y direction, 4. 1, 2, 3, 4. And I put a point there. And then I do the same thing for -3, -3, -2, -2, etc. And you're going to see that these points fall into a straight line. And then to draw the line that contains all these points, you can take a ruler or you can just hand draw it. It's hard to get it exact on the Promethean board, but it should look something like that. And you always put arrows on the end of your lines. Now, if you remember from your earlier math courses, the domain and range are all the x values and all the y values that are possible for that function. In this function, we're looking at the complete function. We're not just looking at a small set of x values, a small set of y values. So for any value of x, is it possible to have any value of y? And is it possible to use any value of any real number in your domain? And in the linear function, it is. There's no real number that you could not plug in for x. So we call that all real numbers, or the interval from -infinity to infinity. And for the linear function, the range, the possible y values, are not limited, or there's no y values excluded from the range. So that means your range is also from -infinity to infinity. Now, there's two types of brackets that you could use for your interval. We call this interval notation. So let's just add a little extra thing here. Interval notation. You might want to jot this down on the back of on an extra sheet of paper, or on the bottom of your sheet. When we write out the domain and range, we use either a round or parenthesis bracket or a square bracket. If we these intervals start at the lowest value and go to the highest value. So if it's if the bracket is on the left-hand side, it means the lowest value either is not included in that interval, or that it is included in that interval. And the reason for the one we just looked at, the reason we use round brackets for infinity is because infinity is not actually a number. It's more of an abstract idea. So we don't say that infinity is included in our interval, but everything up to -infinity and everything up to +infinity is included in our interval. Now, where is my x-intercept and my y-intercept on the graph? Well, if you remember the definition of x-intercept, it is where the graph crosses the y-axis, where the value of y is 0. And that's at the point. Now, this is not interval notation, this is point notation. Let's use a different color for that, actually. So when we draw the point 0, 0, the x-intercept is at the point 0, 0. And in the parent function, the y-intercept is also at the point 0, 0. Now, when we start translating these functions tomorrow, you're going to see that these might change. The x-intercept and y-intercept might change. But for today, it's at the point 0, 0. And you also want to remember, if you're looking in your calculator, that the x-intercept is at the point where y equals 0, and the y-intercept is at the point where x equals 0. Now, one thing that you may not remember from Math 2 is the term interval increasing and interval decreasing. We're actually not going to do that right now. We're going to look at the end behavior. I don't want to look at the intervals increasing and decreasing. We're going to look at that later in the week. So let's look at end behavior. And we're just going to simplify the term end behavior at this point. There's a little more to it than how I'm going to write it, but for your first time looking at it, I'm going to say, as my values of x increases, so as x increases, what is happening to my y values? Well, if I'm looking here, x starts at 0, then 1, then 2, then 3, then 4. And as I go up in my x values, I notice that my y values are also increasing, because at x equals 1, y is 1. Then I increase x to 2, and y increases to 2, etc. So as x increases, y is also increasing. Another way to look at it is to look at the end of your graph. At the end of the graph on this end, where x is increasing, my arrow is pointing up, so the y's are also increasing. And if I look to the left, as the x values are getting smaller and smaller, I notice that my arrow is pointing down, so my y values are going down. So as x decreases, y decreases. So for a linear function, for the parent function, your domain and range are negative infinity to infinity. Your x-intercept and y-intercept are both the point 0, 0. And your end behavior is, we call this down, up. You could say down, up. Or you could say as x increases, y increases. As x decreases, y decreases. The next function we're going to look at is y equals x squared, or f of x equals x squared. And anytime we have a power of 2 in the function, we call this a quadratic function. We have a quadratic function here. So a quadratic function takes whatever value of x I have and squares it, and that gives me my y value. So if you remember, the definition of squaring something is multiplying a number by itself. So in other words, I'm doing negative 4 times negative 4. And this is 16. Another thing you could do is plug this into your calculator and look at your table of values. If you remember how to do that, you go to your y equals menu, plug in x squared, and then hit second graph, and you'll be able to see your table of values. Negative 3 to the second power is positive 9. Remember, whenever you square a number, you're multiplying a negative times a negative. That makes it positive. So those are my y values given the x values that we have in our table. I'm going to go ahead and plot these points. So at negative 4, I have 16, and I don't know that my y values go to 16, so I'm going to skip to negative 3. So I'm going to go to 1, 2, 3, and it's 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. At negative 2, I'm going up 4. At negative 1, it's 1. And at 0, it's 0. Now, if you remember, a quadratic graph has a parabola. It's a shape of a parabola, which means there's a axis of symmetry, and everything is reflected across that axis of symmetry. So these points are going to reflect across the y-axis, because my axis of symmetry is the y-axis in this graph. Or you could just plot the points. So everything is going to be, all these points are going to be reflected across the y-axis. And then just connect your points. And again, as long as you plot the points, I don't care if you're drawing, because mine isn't. I apologize. I can do better than that. Try to get it through the points, but apparently I'm shaky today. Sorry. Okay, so that's your parabola. Looking at this graph, and looking at my table, and even looking in the calculator, the domain, or all the possible x values that I could plug into this, is still going to be negative infinity to infinity, because there are no x values or no values of any real number that I can't square. I can square negative 8,000, I can square negative 8 million, I can square 2 billion. It'd be a really big number, but I can do that. So there's no values of y or of x that would be eliminated from the domain. So that's going to still be my domain, negative infinity to infinity, with the round brackets, because infinity, again, is not an actual number. The range, however, is going to be limited, because when I square real numbers, I only end up with positive numbers. So my range is not going to include, in this parent function, any negative numbers, which means the smallest, the lowest value in my range, or the lowest y value, looking at the y-axis, is 0. There's no negative 1 y value in this function, this parent function. So my lowest y value is 0. Again, I can still go to positive infinity. I apologize. So for some reason my board is going to act funny all of a sudden. We're going to go ahead and see if that helps. So I start at 0, and it includes the number 0. The range includes the number 0, but it does not include infinity. So we have a square bracket on the left and a round bracket on the right. Now let's look at our x-intercepts. X-intercept, again, is where y equals 0. Where y equals 0, x also equals 0. So your x-intercept is, again, 0, 0. Now look at the y-intercept. Where y equals 0, x also equals 0. So your x and y intercept for the parent function of a quadratic is 0, 0. X and y intercepts are both 0, 0. And the last thing we need to look at is not the interval increasing and decreasing. And on your paper, I believe it says end behavior. My end behavior is going to be very similar, well, not very similar, but somewhat similar to my linear graph. So let's look at our linear graph, where we go up on one end and down on the other end. So it's up on one end, so go back to your quadratic graph. You're up on this end, right? As x is increasing, my y's are getting bigger. So as x increases, y increases. But as my x's are getting smaller, I notice my y's are getting bigger. So as x decreases, my y's are still getting bigger. So on both ends, I'm up and up. Whereas in the linear function, we were down and up. So the difference between the quadratic and the linear, let's see. Same intercepts, same domain, different range, because we have a minimum value. The graph stops decreasing here, goes back up, and it never decreases again. So we have a lowest y value at 0, so our range is 0 to infinity. And behavior, and the ends of my graph, I'm going upward in both ends. So as my x's increase, the y's increase, and as x decreases. Whereas with a linear, you had your end behavior down. As x decreases, y decreases, and as x increases, y increases.